In this video, we'll learn how to use the TI series calculator to find normal probabilities or values associated with any normal curve, not just the standard normal. These section corresponds to section 6.3 in the textbook, Applications of Normal Distributions. And what the textbook does is for all of their problems, they convert their values to z-scores, and then they use the table or a calculator to read the z-scores. We're going to learn how to do both. You might get a slightly different answer due to rounding. So I just want to make sure that you know both ways to do that. The fastest way is to not use the z-score. Alright, our first example. What proportion of women are eligible for Tall Clubs International? The social organization Tall Clubs International has a requirement that women must be at least 70 inches tall. Given that women have normally distributed heights with a mean of 63.8 inches and a standard deviation of 2.6 inches, find the percentage of women who satisfy that height requirement. So what you'll do in the textbook goes through, first of all, how to find the z-score and turn this into a standard normal. That means that they'll take the 70, subtract the mean, which is 63.8, divide by 2.6, and that would be 2.38 standard deviations above the mean. Then what they'll do in the textbook is use the table or technology to find the area above 2.38 standard deviations from the mean. So let's do that first. So a reminder on the calculator, our distributions are, you hit second and then the variables key. Written above that is DISTR, which stands for distributions. To find areas, we use option 2, the normal CDF. And to find an area corresponding to 70 inches or taller, we're going to find the area first of z-score of 2.38 or greater. So we type in our low value in the interval, 2.38, comma. We're going to shade in all the area to the right, so that would be to infinity. Our calculator doesn't have an infinity key, so we use 1 times 10 to the 99th, and we put it in scientific notation. So we type a 1, second, if you hit the comma, there's an EE above, that means times 10 to the power of 99, comma, so that 1E99 represents infinity. Standard normal has a mean of 0 and a standard deviation of 1. And when we hit enter, we find out that 0.008656 is the probability that, or it's actually, if you change it to a percentage, that's 0.866 about. So less than 1% of the population of females is taller than 70 inches. Actually 0.866%. Alright, now let's try the problem again without converting to a z-score. Our calculator will read any distribution, not just the standard. So we go distributions, normal CDF. We can type in the value of 70 inches to infinity. And this time the mean is, what's our mean? 63.8 and a standard deviation of 2.6. So our calculator will allow us to not have to do z-scores first. It will read any normal distribution. You just have to put in the mean and the standard deviation. Hit enter. Notice that we get a slightly different answer, however. It's a 0.008548. Okay, so when you're using My Math Lab, and if you're using the calculator and somehow it just won't take your answer, you may, when it gets, you know, these smaller rounding to the thousandths, 10,000ths place, you might have to find a z-score first. But in most cases, the calculator will give you exactly the same, up to 2 decimal places. So which one is more accurate? Well, the calculator is actually more accurate because when we're finding a z-score, we generally have to round. And then when we're finding the area based on just the z-score, then our area is going to be a little higher if we round it up. It'll be a little lower if we round it down. All right, so either way, this one you get about 0.85%. Okay, so just wanted to say you can use the calculator without changing to a z-score, but for my math lab, they'll consistently find z-scores and find areas based on that. All right, let's look at our next example. The airline flight crew requirement. All right, in our chapter problem, it stated that British Airways has many other airlines have a requirement that a member of the cabin crew must have a height between 62 and 73 inches. Given that men have normally distributed heights with a mean of 69.5 and a standard deviation of 2.4, find the percentage of men who satisfy the height requirement. All right, so in the textbook, they'll find z-scores first. So they're finding a z-score that corresponds to 62, and that's a z-score of a rounded negative 3.13, and then a z-score that corresponds to 73 would be 1.46, and then they will find the area between these two. Okay, so let's see what this answer right here is from the textbook, so let's see how our calculator does. All right, we go to normal CDF, and if we type in, we want to find out the area between a height of 62 and 73. So this time the low number in our interval is 62, high number is 73. We have a mean of 69.5 and a standard deviation of 2.4. End parentheses, and we get about 0.9267. So if we round it, that's 0.927. So in this case they were consistent, mainly because we didn't go out too many decimal places. So that means the interpretation is about 92.7% of males satisfy the height requirements to be a cabin crew member. All right, third example. This one is designing aircraft cabins. And in this case, we're going to take a look at when designing an environment, one common criterion is to use a design that accommodates 95% of the population. What aircraft ceiling height will allow 95% of men to stand without bumping their heads? That is, find the 95th percentile of heights of men. And assume again that heights of men are normally distributed with a mean of 69.5 and a standard deviation of 2.4. So in our diagram right here, we have the area and we're trying to find a corresponding height that goes with it. We're going to find this directly using the inverse normal. You type in the area to the left, the mean, and the standard deviation. Again, what your textbook does is they go through and find the z-score, which would be a 1.645, and then they convert that back to a height. Using the calculator, we'll take out that middle step. So inverse normal is under distributions again, and it's option 3. And this is type in the area to the left of the score we're looking for. So the area to the left is this 95. So we have 0.95. And then the mean of our heights is 69.5. And then the standard deviation, which is 2.4. Close parentheses, and this will give you the height directly. So this says that a height of 73.4 inches is at the 95th percentile. So that means that an aircraft cabin height of 73.4 inches would allow 95% of men to fit without bumping their heads. Okay, so the actual cabins in most of the planes are a couple of inches shorter than that. All right, last example, we're going to use that inverse normal again. And this one says some educators argue that all students are served better if they're separated into groups according to their abilities. Assume that students are to be separated into a group with IQ scores in the bottom 30%, a second group with scores in the middle 40%, and third group with IQ scores in the top 30%. The Wechsler Adult Intelligence Scale yields an IQ score obtained through a test, and the test scores are normally distributed with a mean of 100 and a standard deviation of 15. Find the IQ scores that separate the three groups. So on our inverse normal, again we have to put in the area to the left. So if we're trying to figure out the score that goes with this first group right here, we would put in 30%. So we get to our inverse normal, 0.30, and then we can find it directly by passing z-scores by typing in the mean, which is 100, and standard deviation of 15. So this gives us a cutoff IQ score of about 92.13. And then we do the same thing for the next cutoff, except we have to again think about what's the area to the left. The total area to the left is 70%. So in this case we put in a 0.7 for 70%, mean of 100, standard deviation of 15, and then we get a cutoff of about 107.9. Alright, so using the calculator, again, it's the most exact, but your textbook sometimes they convert to z-scores first. So in this case, if they convert to z-score of a 0.52 on either side, and then use that to find the actual scores, there's a little rounding error. If you're using the z-scores rounded to two places, results in an answer that's slightly different. They get 92.2 to 107.8 instead of what we got, which was 92.1. That should be a 92.1 right there. 92.1 to 107.9. Okay, so again, the calculator is a nice shortcut, but sometimes you've got to follow the z-score. You can still use the calculator to find the areas that go with that, or to find the scores. It's just that might be off a little bit on the rounding. So calculator's the fastest way. If you're off a little bit on rounding, you still have the backup of finding z-scores and then finding areas, or finding z-scores that way. Or taking the z-scores and using those to find the IQ score that corresponds to that z-score. All right.